Hey everyone, today we're doing a continuation of solving inequalities. We're doing some more practice with that. Still looking at it in context. Remember, in context means in the real life situation, in a context that we might see out in the real world. And there's just a couple of reminders here on your handout I want you to take a look at. It's reminding you some problem solving strategies that we'll need for this first page, and it's identifying some keywords that we'll see often with inequality symbols. Please take a look at those as you continue on with your handout. But for today, we're going to look at this first situation, do it together, and then you'll be able to do the rest as a practice. The first problem says Ella has $500 in a savings account at the beginning of the summer. She wants to have at least $200 in the account by the end of the summer. She withdrew $25 each week for food, clothes, and movie tickets. Write an inequality that represents Ella's situation. So let's go back and identify those problem-solving strategies, identify that key information that we'll need. So she has 500 in a savings account. She wants to have, here's a key word there, at least 200 in the account by the end of the summer. She's going to withdraw $25 each week. Okay, let's set that up. So the thing that's unknown and what we're going to answer in the second part is how many weeks can Ella withdraw money from her account? That's our missing information. That's our variable. And let's use W to represent weeks. So each week, that unknown number of weeks, she takes $25 out. So that could be 4 weeks or 10 weeks. But whatever that number is, we're going to multiply it by 25 because that represents the amount she's collectively taking out in the summer, depending on how many weeks that is. Now she's taking money out, she's withdrawing money, so it's coming out of her account, and it's going to be removing some of that $500 that's sitting there in her account. So we're going to subtract it. We're going to compare it to what she needs to keep in her account, which is 200. And remember, she wants to keep her balance, her account balance, above 200, or when it says at least 200, it means it could equal 200. So we need to either equal $200 or we need to keep the account above or greater than 200. So that's the inequality that we're going to use to represent this. This is what is happening in her account. This $500 is being reduced $25 each week, but as long as we keep this amount greater than 200 or equal to 200, we are good to go. So when the question asks how many weeks can Ella withdraw money from her account, now we're going to solve for W. So just like an equation, we're going to do the inverse operations. We're going to do it to both sides to keep things balanced, and we will ultimately figure out what W equals. So let's do that. Now, this one's a little different than most of the equations that we solve. If you thought the inverse operation I need to do is add 500, you would be incorrect, and I'm going to explain why. So be very careful here. So in subtraction, we can't just reverse things. So this is not a subtraction problem where we're subtracting 500. That's not true. We're subtracting this variable from 500. So what we need to do is get rid of this 500, but we need to think of it a little bit differently. So since we can't reverse the order of subtraction, we can reverse the order of addition if we turn this into an addition problem. Now remember, we can turn that into an addition problem if we add the opposite amount. So if we make this 25W negative, then we still have an equivalent expression here. Now that it's addition, we can look at this as removing this plus 500. So what we're actually going to do, for the inverse operation is we're going to subtract 500 from each side of our inequality here. That will cancel this part out and leave us with now negative 25w, and 200 minus 500 is negative 300. Okay, our next step, get rid of this times negative 25 here. So we'll divide by negative 25. These will become 1, and 1w is going to equal, dividing two negatives is going to give me a positive quotient, and it's going to be 12. Now the last thing I have to determine is, does my inequality symbol stay the same to be greater than or equal to down here, or did it reverse directions? So let's think about our situation. So we have W representing the number of weeks that she's taking money out of her account. We said that equals 12, so we know that our symbol can still have that equal sign there. Now we need to decide, could the possible answer for the number of weeks, should it be less than 12 or should it be more than 12? Well, this is each week she's taking $25 out of her account, and we're trying to keep that amount above or greater than $200. So if she keeps taking money out, more weeks taking more $25 out, she's going to dip below the $200 she needs to keep in her account, and that's going to be a problem. So we do not want to keep the symbol the same, because that would mean that we would have more than 12 weeks of removing her money, removing $25. Instead, we want the weeks to be less than 12 or equal to 12. Okay? Now we're going to apply this idea. I do want you to do the rest of these problems, and then we'll talk about the next part. So here, we're looking at some inequality statements, but they're out of context now. So we don't have a situation or a story to look at. We just have an inequality to solve and then determine if x is greater than 4 or less than 4. That's what we're going to be looking at on the back side of this. Because there's not any context, we can't look at this and say that, oh, we want our values to be bigger or less than 4 because we understand the situation. Now what we need is we need a process to understand this. So if we go back to some of the situations that we looked at on the front side of the sheet today or on yesterday's lesson, there is a pattern here. Every time when we're solving these inequalities, every time we either divide by a negative number or we multiply by a negative number when we're solving, what happens is our inequality reverses direction. Our inequality symbol reverses direction. Okay, so we have to look at how this inequality would be solved. If we're trying to isolate our variable, instead of adding 5, we would subtract 5. Okay, that's not going to multiply or divide by a negative number, so our symbol stays the same. That means that our answer would stay as E, and we would keep using the greater than symbol that was in the original problem. But let's look at the next one. In solving this, negative 6x is less than 12. To solve it, we would have to divide both sides by negative 6. So because we're dividing by negative 6, this less than symbol reverses direction and becomes a greater than symbol. All right, please write this down, that the inequality changes if we multiply or divide by a negative number. That is the only way that we would use a different symbol here, is to multiply or divide by a negative number. So let's look at the next one. Negative 5x is greater than negative 20. To solve it, to cancel this times negative 5, I'm going to have to divide by a negative number, negative 5. So this greater than symbol is going to reverse to a less than symbol, and it would be right there. Okay, that's it. That's the simple process to this is, again, if we're solving an inequality, if we have to multiply or divide by a negative number, the inequality changes. That's the only case. So go through the back side of this handout, identifying if it changes or not. Use the letters in the puzzle to fill in the code at the bottom, because that's going to tell you if you solve them correctly and kind of check your work. All right, I'm happy to answer any questions, but today is a chance for you to make up some of the missing work that you might have, or your iReady for this week, or get caught up on some of those other practice problems. Have a great day.